let's start. I can show what the progress is, at least from my side. Yep. So first of all, I published the converter enclosure. So here are the comments how you can run, and I just do a few transformations in future. So potentially we can add more. And if somebody wants, he can implement in a different technology the same converter. The conversion is quite simple. So if we go to transform, so that's all. And it has some helpers to translate IndiGJSON to IndiGJSON, zipped or non-zipped. So everybody welcome to contribute. So, and yeah, we can make like switches, so we can turn on, turn off some features and then play with it. So the next, I think it is interesting. So I created this interactive demo. For now, it's only Postgres and DuckDB, but I'm planning out the Spark, SQL, BigQuery, and whatever you guys think it works. So, and now you can run, let's take some simple query, like, oops, it's broken, okay. I changed the format. Yeah, these queries. So if you pick the specific database, then you can call execute. Here are the samples. And if you have interesting samples, so feel free to save it by clicking the save button, give it a name. So as Josh proposed, I will create some, so the ability to create the links to different queries. And we will be able to share these queries and test against multiple databases.
Nikolai, not to add too many development items for you, but if you could add like tags or some kind of organization to the queries, I think this is, you know.
Yeah, I was thinking to introduce like a username. Yeah, username. Yeah. So yeah, but I can do this. So
cool.
So
by the way, this is an awesome playground. This has been super helpful testing queries, even just so far.
So yeah, I had been thinking about this. I didn't have time to do anything because I have a day job, but why wouldn't we target ANSI SQL 2016? That's the spec, and then your translator would use that instead of inventing a DSL. Like why would this DSL be in the specification that we're trying to put together?
Yeah, again, so
we're like
talking about this
detail of how you would take like an ANSI SQL approach and adapt it to a whole bunch of database engines.
It doesn't adapt it. So even I've tried just implement few macros. So that's the next topic. So yeah, so I described this macro in few functions, and the most important is a simple pass expression, which is really different in different databases. Like in DuckDB, the enumeration started from 1.
Right, I get it, but is there no standard ANSI SQL way to express this? And shouldn't that be the kind of specification? And
do you mean JSON pass or what?
Yeah.
Yeah, JSON pass is really complicated. At least what I think the columnar databases will not support it quickly. So the interpretation of JSON pass, so I can show the samples.
Right. No, I understand that they're not going to support it, but I'm just saying instead of your macro here, have you thought about translating the standards representation of JSON path instead of this proprietary DSL macro language you're making?
I don't know what to answer. So I'm trying to answer you. So you can suggest different solutions. So please come and bring how the JSON path can be used for that, how the translator may work. So please do this through the samples and some proposals.
I guess, are we trying to solve a database abstraction problem or a specification of how to do it? And then each database engine might have its own.
That's true. And yeah, I encourage you to try, because unless you try, you will not understand the details. So please go and try in different databases. So we have playground, or you can create your own playground, try in different databases. So you can see that's the Postgres, that's the DuckDB. And here is a nest, here is a JSON-B array elements. The DuckDB is, I don't know, counting from 1. The Postgres counting from 0, if it's JSON-B, but counting from 1 if it's array in Postgres. So try it, and then please come and bring some proposal how we can do it in ANSI SQL or something else. So this is just a hypothesis. I'm not driving this. This should be public decision. So that's the smallest what we can do to unify the queries. I can show the sample. So for example, Josh, and that was very nice. So Josh bring this very interesting query, yes, which looks like real. And we're starting go through this. So initially it was written for DuckDB, initially it was written for BigQuery. Then, yeah, I created the copy for DuckDB. Josh, yeah, created another version. And at the end, I was able to run this query with these few macros on both on Postgres and on it's slow, but it's okay, and on DuckDB. And this is very nice exercise. So I think we can test different ideas this way. So can we do this or not? So, and if we will have nice list of databases, that would be quite interesting to explore.
I think Dan was first, so go ahead, Dan.
Oh, sure. I'll be quick. So I do think, so I like the macro approach. I kind of share a little Brian's apprehension about creating a new DSL for databases or new macro system, like query preprocessing system, because that's like pretty far from, FHIR specific stuff. So, but I'm certainly open to the fact that we may need to do that because maybe, it's just an easier way to represent FHIR patterns. The one alternative that I think is worth considering is potentially writing to a base SQL syntax and then translating to other SQL syntaxes. So if you look at how, I can provide some links, but one of the ways OMOP does this for their data warehouse, they write to SQL Server as their base SQL dialect, and then have a translation engine that compiles it to Oracle and a couple other databases. There's also a Python project called SQLglot, which parses SQL into an AST and then generates different SQL dialects from it. I think the way to do that is you do have to define a somewhat constrained set of SQL, but things like date functions and stuff are pretty easy to translate once you have them in an AST. I think, and I guess I'm wondering, like, if we use like a basic unnest pattern, which works across a lot of databases that use structure as well as databases that store native JSON, like I wonder how far we could get with that, where we like write a very clean Postgres query if we choose that as our base, or SQLite if we choose that as our base or something, and then translate that into a couple other database engines, by altering those pieces. So to be fair, I have not actually tried this yet. So I think it's, I think it's fair, Nikolai, to be like, bring some code. It's going to take a little while, but I don't want to completely dismiss that, because I think the farther we get in terms of like developing our own DSL, like the more tooling we're going to have to maintain over time, and the weirder it's going to be for people writing queries.
Yeah, but you're talking about reinventing the SQLs, like the whole interpretation of the SQL, yeah? Which is from my point of view a couple of orders of magnitude more complicated than create a macro system. So.
I guess I'm saying that we write to one SQL dialect, and that can either be translated manually or down the road in an automated way to other SQL dialects, and try not to use like features that wouldn't be available in other dialects, which I think we're kind of doing anyway with the macro system. So it's really, I don't know that I would say that we're inventing stuff there. I think all we're doing is saying, if we write the queries in a fairly basic, fairly portable way, like that same query could be recreated with the same structure for other databases. Right, like you did that when you wrote a query that works in both Postgres and DuckDB, right? So that's already, and
that you can start and kind of compare these queries. They're completely different. So that's.
Well, yeah, I feel like DuckDB is a little bit unfair here because they're not supporting kind of a lot of the core SQL features we need.
But essentially, it's
in the current
almost
version.
like Spark SQL and BigQuery will behave. So I will add it this. I
Yeah,
don't
so
see
I guess
it
that's
as
my
big difference.
question.
Yeah.
Like
Yeah.
BigQuery versus Postgres, like I think they could be very similar.
No, they won't be. They maybe will be very similar in some basic construction like a nesting, but even in
Yeah.
Postgres, you don't using a nesting. In case of JSONB, you are using JSONB elements. So
Right,
that's
but you have the
thing.
same query structure. It's just a different function in
Yeah,
your
yeah,
join,
exactly,
right? So
yeah.
like, I guess my point is like you're translating one join syntax for another join syntax, but you're not changing the structure of the query. So you would have to like change your date formulas potentially, or you could use like a DBT macro for that.
Yeah, that's exactly why this
But, like,
macro is working here for both databases. For me, macro is
Yeah.
just more lightweight and easy to implement solution. But if we decide to try to write the dialect, parsers, and translators, okay, let's do it. Let's make the prototype and let's review it. Sorry, Ryan.
Yeah, no, this is a good discussion. Yeah, and I think that maybe that they're starting to get a little closer to the one of the cores of the issues. I suspect that a lot of this group is kind of starting from different objectives and different sort of maybe values and trade-offs, and which decision make here is really going to depend on the objective that we're trying to achieve and where we place our values. And so there's trade-offs between perhaps an ease of implementation and like a more sort of thorough, well-defined, more portable spec across databases and a bunch of dimensions there. So maybe I feel like maybe we want to kind of get on the same page if possible with regards to what our objectives are in this space. And I am sympathetic to some of the points that I think Brian and Dan, one, I'm sympathetic to the ease of implementation, I think is quite important, but at the same time, a very sort of a thorough specification, which I think Dan and Brian and others have mentioned as well. I mean, I would love to have no matter what approach we have, I'd love to have like a very well-defined semantics that could be moved across databases and to create flattened views. Yeah, and of course I have my own objectives and perspectives as well that I want to consider in this space too. But I feel like we have something different. Maybe we start with what our goals are and what our values are, and then we can have more productive discussion.
Mm-hmm. But what is your vision? So how do you see Ryan? So like, can we end up with a dialect of SQL limited to the common denominator for all databases?
Yeah, so well, again, I think that's I think maybe I'll step even further back, and I think that an objective that I would like to advance towards is have a well-defined standing on existing standards as much as possible, have a well-defined way to describe flattened views of FHIR data that are portable across many database implementations.
Mm-hmm.
So I think that in a kind of a really short nutshell, and I think that when it comes to values, which I think is important here, I do place some value on being able to leverage existing standards as much as possible, and particularly in the FHIR community. So, like, I mean, full disclosure, I mean, it's like that draws me towards FHIR path a little bit, but I don't want to get down there. Or at least a subset of it, because it's an established standard with very well-defined semantics. Is there a way that that could be translated in that? If not FHIR path, then some other existing standard that maybe we could build on. I know that ANSI SQL has been proposed. I know that JSON path has been proposed. I think those are worthy options as well. I don't think that this necessarily precludes building a new macro language, but I think that where it gets into like somewhere the values might be a little bit different. Like, since those of us tend to value let's lose existing standards as much as possible, that there's some resistance to wanting to create a new macro language. And I think that's what we're seeing here. And I feel it myself a bit. Yeah,
that's good objective, but I encourage guys you to try because
Yeah, so and we've done just sort of cards on the table as well. Like, we've done some experimentation within Google and some open source projects. This is in a variety of maturity. I don't think I'm quite prepared to show some stuff today, but where we think it is possible to translate a pretty large set of FHIR path expressions into SQL that will port across engines, and we've done some proof of concept work that translates FHIR path to run on BigQuery and on Apache Spark. And so maybe we can plan a future session, we can kind of demo that sort of thing. It is significantly more complicated, essentially because we have to build an AST of the FHIR path and then translate the FHIR path AST into SQL. is that complexity justified? I think that's where it gets back into what the values are.
Yeah, that's true. Because are you just compiling this, transpiling this to some unnests and filters? So how is, or you just implement FHIR like a function for BigQuery? Because I think it's possible to, at least for Spark SQL, you just can go and use a Java implementation FHIR. But when we are talking, potentially it can be done for DuckDB. Yes, so that's interesting version. If we potentially can write FHIR a native implementation for a bunch of databases, that's good. Yeah, but if you're talking about like, I don't know, AWS, RDS or something like this, so that's what happened with our extension. So it almost got to AWS, but almost. So it's not in Aurora, so and it is hard.
Yeah, so to answer that, and I saw Evan raise his hand, so I'll answer that quickly and then pass it to Evan. But yeah, so the stuff that we've done does translate FHIR to both the BigQuery SQL dialect and the Apache Spark dialect, which are different enough. I mean, an Apache Spark uses a very similar dialect as you'd see in like, I think it's what you see like in AWS, the what's their Athena product there. So they're sort of their BigQuery alternative on AWS. So I think there's evidence that it actually generates SQL that is portable, and it does use the appropriate unnest or lateral view explodes or whatever variety of that. I could see a translation that would translate into that JSON model as well. So I think it's doable. It does come with complexity, so it does mean taking the FHIR path, building the AST, and then recursively translating the FHIR path AST to SQL. That seems pretty valuable, and I'd be happy to maybe collaborate on that effort if that seems promising. The thing that does feel, but I think that's appealing to me because of some of the values in terms of one, standing on an existing standard, and two, I also really like that because it actually opens up other opportunities as well. Like you can, I mean, even if you just have like a pile of ND-JSON or something like that, if your columns are described by FHIR path expressions, you could just translate those right into a data frame. So I think it gives many opportunities there. But yeah, I think that maybe this is something we can jump into later this week. I don't want to monopolize the conversation today.
Awesome.
But yeah, so anyway, I saw Evan has had his hand up for a bit, so I'll pass it to him.
Yeah, I mean, my interests align heavily with what Ryan and Google are working on. CQL is a superset of FHIR, right? So theoretically, everything that is supported in FHIR is supported in CQL. So I want to do the same thing, right? The issue is, and what stopped me previously from embarking on that a year ago, 2 years ago, was that I can handle the FHIR stuff, I can handle the CQL stuff, but how am I translating that SQL? What columns am I targeting? What JSON paths am I targeting? And do I have a reasonable expectation that anyone will have a database schema that I'm translating to? And that's my primary interest in this entire project, is that all of these use cases are possible where we could create we could create software that makes other existing FHIR tech like FHIR, like CQL, portable across many different databases. We can give customers the value proposition of ETL your FHIR data into this schema, whatever that is, whatever it looks like. Once you do that, you can now use this software to do FHIR against your database, do CQL against your database. And that to me is a major win. So, that's really what I'm looking for. I would just second Brian's opinion. I think I kind of made this point last week as well, which is that, macro languages, you have to think about who is going to be writing those, right? Who is going to write a query that is cross-platform? The only people who are going to do that are people who are trying to create a tool or a product that would be portable across different customers who are using different stacks. If I am working at a company that's invested in Databricks or BigQuery or one of these technologies, I'm only going to write queries against, that I know will work in that environment, because I'm not planning on making my queries portable, right? So if I were to sit down at my company and say, okay, I'm going to start doing analytics on my Spark stack, I'm not going to start writing a macro language because I don't care that it's going to work on Duck, right? I only care that it works on my environment. What I would like is to have a situation where I'm sitting down, I'm writing my Spark queries, and as a convenient side effect, those happen to work on other databases as well. That would be cool. we shouldn't ask people to have to do something special to enable what they're writing for queries to work on other stacks. It should just happen, right? It should by default do that. And I understand that that's somewhat impossible if we allow people to write bare metal queries against their customized stack. So to Brian's point, he was suggesting, well, why don't we say it has to be ANSI SQL, right? And then if you have to translate that using a tool like this SQL glot tool that Dan brought up, then we can do that. One of the first things I ever did in my career was translate T-SQL queries into ANSI SQL queries because we were trying to migrate a product to support SQL Server 2005. And it only supported SQL Server 2000. And we couldn't rewrite every query in the application. So instead we wrote middleware that translates it. So I know that's possible. I've done it myself, and I did it in C with pure string pointers because it was that time, that era. But, it's possible. Whether it's worth
it is, yeah. Let's try.
Point,
so
right?
even that's very nice to dream about this, but I suggest to try, because if you've seen the last specification of ANSI SQL, there is no database now on the planet who support all of this. So, and you're going to use it.
I would ask, how does SQL glot work then? How do they implement that? How does it work?
Yeah, the JSON pass was released like 5 years ago, 6 years ago. Only Postgres support the nice the almost full specification. Even Oracle doesn't support most of expressions. Yeah, so that's crazy. So that's nice. We can use this standard, but I would be pragmatic. So let's do something working, which is really work on most of popular technologies. Yes, we can maybe that we can translate everything to everything.
If nobody supports this JSON dot notation, because even though ANSI SQL released a spec for it, 8 years ago now, and still no one supports it, then why are we going down that path?
Okay, just dot notation is supported, but if you're talking about JSON pass, it's a different language. It's a language with the filters inside, with a bunch of stuff like up to the JSON table. So it's complicated like FHIR pass. So the FHIR pass can be translated to JSON pass, but the problem that the only database support JSON pass is the Postgres and a little bit Oracle. So that's, most of databases support just dot and index and maybe something very small stuff.
So are we? Maybe I missed something here, but have we decided that JSON path is absolutely critical to this project?
No. So we're trying to reduce it to very, very simple pass access language, and I think that's what Ryan keep in mind, that this very, very small subset, because what we need just getting by elements, indexes, and probably do some filters in between. So if we have this and filters by like pattern matching, so just this field equal this, that would be enough for us to do like 80% of what we want. The question is how it could be expressed. Yes, is it going to be JSON pass, which is not supported by anything? Can we translate this subset to unnests and filters? Potentially, yes. Yeah, but I see that a lot of it's quite difficult. So to write this compiler, yes. So, or just use unnest and very, very basic access patterns like I did in macro, and just guys will write like CTEs or views to flatten and then use standard SQL, flattened SQL to work with this data. Okay, sorry, Bashir.
Yeah, sorry. Very, very interesting conversation. And I apologize, I haven't been able to join the last few weeks. I have been traveling and last week I couldn't. So just making sure that I understand the goal of, that we are pursuing, because in the first meeting that I joined a few weeks ago, I think it was more about, the schema and then, how it's actually being represented in different databases, like, whether it would be columnar or JSON or whatever, right? And now I think the discussion has been shifted more to a conversation around how to specify queries which are independent of how we actually represent the data at the database layer, which I think, I just want to make sure that, if my understanding is correct, and I think it's actually the right approach, like Ryan was saying, that if we can come up with like a specification or something, I don't know, for the lack of better word, that, how you specify the queries against FHIR resources, and it's completely independent of database, right? So I have resources, and this is how I say how I can fetch this data from my patient, and then how I want to join it with observation and things like that. And then once we agree on how to do that, whether, I don't know, it's ANSI SQL or JSON paths or FHIR paths or whatever, then it's a separate question to implement adapters for getting those queries and then running it against different databases. So I think I like this approach, and I have seen, like, one of my colleagues on my team actually worked with Ryan's team to implement the prototype that they had for BigQuery, and then adapt it for Spark SQL. And the difference is actually quite significant. So, I mean, it's a non-trivial thing. Although, I mean, it was both SQL on FHIR schema, both columnar. It was just BigQuery's dialect versus Spark dialect. And the work is quite significant. It's definitely doable, but quite significant. But then the thing is that, you do it once. And then I think the benefit of having one the same way of specifying the query is that then those specifications or those queries become portable. So for example, if let's say Ryan's teams have created 100 metrics for data quality, for example, right? And they just care about BigQuery. But if they have done it through that generic specification, then I can take all of those and then apply them to my Parquet and Spark SQL database. Someone else may take them and apply them on NDJSON files.
Yeah.
So I just want to make sure that, that's what we are aiming for, or are we still thinking about, what is the schema?
Yeah, that's exactly. I would say we have Ivan, who is on NCQA side, and the guy's interested to write the portable queries or portable programs to do the hedges metrics and all this stuff, and then give it to the world. And different organization will run it using their technologies. Yeah, so yeah, that's the goal. So, but we are trying to find what the right way to get to this point.
So HL7 defined this clinical query language, right? It's a query language, but it doesn't run on databases yet. I want to enable that really, really badly, because right now it's being run with,
Is it query or quality?
Query, it might be quality, actually. I should probably know
I
this.
think originally it's quality.
It's a query language. They can call it whatever they want, but it's a query language. It's basically SQL with a little bit of different syntax, right? So, running this stuff on your own PC or a server or something by pulling down your entire database and executing is crazy. We should be executing this in the data stores where they live, right? Just like any other query. So that's my primary interest. Yeah.
So I think there's a good discussion in the chat that Brian and Nikolai brought up, and Brian responded to as well. It's like the goal of the goal of this effort. I mean, is I think Brian was asking, hey, I think originally, we had started like, can we define an SQL and FHIR representation that works well with ANSI? And that was the original goal. It does seem like we are shifting a bit, at least in these conversations. And the shift isn't a bad thing, but I think we should make it an explicit decision. We're shifting from a perspective of trying to have like necessarily having a pure ANSI SQL model for querying FHIR to having some standard to describe tabular views of FHIR data. And just because because of the variance, the pragmatics, and I think someone pointed out there's stuff in ANSI SQL that showed up 8 years ago that's still not properly implemented. So maybe is that like maybe that's worth touching on? Is that like an explicit shift we want to make? Is the goal here to have some as much as possible some standard way to describe flattened views of FHIR data, whether that's JSON or ANSI SQL or FHIR paths or something, but maybe that's our goal and a way to describe flattened views. Would folks agree with that?
Yeah, I think so. Now we have kind of two ideas, yes. So one idea to have deeply nested FHIR structures in some schema and run SQL queries right on top of it, because modern databases like columnar and binary JSON support this feature, yes. So I would call it this kind of the vector 1. Yes, so that's what we're trying to explore. The vector 2, which looks very nice, that we can describe the flattened views, and then potentially, yeah, and the kind of industry is ready for flattened stuff, and then we can use kind of all the standards, all standard tooling like BIs and drag and drop stuff, and we can provide a framework how to describe these flattened views. Potentially, maybe the framework how you can get from JSON or I don't know Parquet to this flattened view in one query, yes, on ELT pipeline. Yeah, and then set of useful queries on top of this flattened, standardized, but standardized for specific use cases.
I would agree. I kind of think some of this is maybe the result of our shifting to kind of two or three levels of query design, or 2 or 3 levels of kind of SQL on FHIR, where the base level is like maybe a somewhat optimized hierarchical schema that's either JSON or native types nested. And so I think we talked about that a lot initially, but also recognizing like querying that directly has a huge amount of variability in databases, or not a huge amount, some variability in databases in terms of how that's unnested. And to Evan's point about wanting to plug in legacy data, like you probably wouldn't want to convert your legacy data into that schema first. And so having a set of flattened views that can kind of power the analytics and the reporting makes sense. And so I think where we are is trying to figure out how you get from that lower level view into the flattened views, and also have a tight enough definition of the flattened views that people can map legacy data directly into that sort of schema. And so I guess from my perspective, it sounds like we have 3 options that we've talked about. One is some sort of pure representation of that, which could be like, something standardsy in the FHIR world, or something we come up with JSON and FHIR path, or something like CQL that's like a pure definition language that's invented from scratch. It sounds like another option would be, and this seems maybe not super popular, but would be to write to a base SQL schema, a SQL syntax, and then translate to other syntax, either manually or through some tooling. And then maybe a third option would be some sort of macro language that we define, which could be a FHIR path-based language, maybe mixed into SQL, so that you could write a lot of common things, but the FHIR pieces that are complicated for flattening could be written in a standard way. So at least I'm curious if there are other options I missed, but it sounds like we're really talking about the layer to get from nested data into flattened data, and also enough definition so other people could just create the flattened data directly. And like which of these like 3 options is a good way to do that?
Mm-hmm. And I would say
is that a reasonable summary? Yeah.
There's still use cases for nested data, because if your BigQuery or Spark SQL works, and you can write this query which will potentially run, you don't have to flatten. Maybe you can create the view like not materialized view, yes, and use it, because because if we're talking about some population analytic, nobody wants to replicate this terabytes and terabytes of data, yes. So so this view definition should be kind of logical. So if people can leverage the like nested like columnar databases or binary JSON and run these views more efficiently by disk, yes, by space, so then okay. If not, so then they can switch like to materializing these views, creating some ELT pipeline or something like this.
100%. And I've been infected a little bit with the DBT mentality of like, you define everything as select queries, and like how it gets materialized is an implementation decision, not really a core to your logic. And so whether it gets materialized as a table or a view or a materialized view, like those are kind of implementation decisions based on how, who's structuring the database. But like, so I totally agree with that point.
I plus one as well. Yeah, go ahead.
Yeah, from methodological point of view, I would like to go like FHIR do, so trying to implement something and see how it works. So for this, I think important to have use cases some queries, some reports which we want to build, and then work around this, trying FHIR paths, JSON paths, I don't know, just nesting and all this stuff. So, and then for me, for example, the macro could be the first step to the SQL translator, because it's much simpler. So we can play with it, identify what are problems between databases, because the next step could be, try to challenge the translator.
Yeah, and Josh brought this up a little bit in his comment, but it's something that I had, I guess, articulated, but I think is really important for us, is like one of the real challenges in flattening seems to be like arrays of arrays where you want to pick items at both levels. And so I think the systolic blood pressure query, hypertension query that we've been playing with is a good example of that.
Yeah.
But that's, to me, like maybe a great initial use case, because that's one of the things that differs by SQL and is like fairly complicated because it has nested on nests. And so if we can handle that, I think like that's a good starting point for looking at other use cases also.
So I think we need the use cases, we need different implementation. We can go through this, try to make some kind of portable query, yes, and see can it work, or even manually write just for different technologies, put it together and see the difference and try to, because we potentially may fall back to just, so people will, I don't know, NCQA will publish just like 5 SQL queries for every popular technology. So let's talk about some plans maybe. So I would like to add more databases and proceed with this macro experiment. So I can create kind of login, and let's create a lot of examples, kind of similar queries, so we can kind of compare and reason about this.
I mean, to that point, I guess I wonder if even before we do the macro piece, it would be helpful to, like, in the repo, create 5 versions of the same query for different databases. And then like we can kind of abstract the parts that are different into macros and or SQL translation, but just to have that baseline of like, and maybe we start with the systolic blood pressure query because that seems to exercise some stuff, or I'm open to whatever, but like, and maybe we have a couple of these, but like, I guess it'd be great in the GitHub repo to have at least one version for each database, but maybe multiple versions for each database, or in the sandbox. But I guess like before we even like start, or not necessarily before, but like separate from the effort of like building translators to actually know what we're trying to translate into. Is it kind of like your idea, Nikolai?
You could have scenarios with expected FHIR, and then where you could have test fixtures effectively.
Yeah, that would be awesome. Like if we had some FHIR bundles or NDJSON files, I guess in this case, of some sample data, and then a bunch of queries that where we would know what the results should be.
I think thousands of questions from Cynthia works well for the start. So we're writing very specific queries here, so we can.
I guess I mean the scenario more about what you're trying to query for. So the scenario is less like the fixtures are less about like Cynthia patients for sure. We don't need to manage that, but
I guess I'm saying
in a use case, I would like to get the systolic and diastolic blood pressure. I would like to get the provider for the most recent encounter. I don't know, like scenarios like that.
We can create most recent per scenario, describe the scenario, and put different implement like sequels.
Right.
Like integrate demos, the sandbox, so it will show all these queries from Git repo, and you can run it.
Yeah, and also if we could upload the maybe have this handy, Nikolai, the NDJSON files that you generated with Cynthia, so that people can load them into a local database to play with a little bit.
Yeah, that's why I published the disclosure implementation, so I can just dump the I can publish files.
Yeah, cool. Okay.
The instruction and closure implementation, how you can translate directory of NDJSON files in one run, so it will create zipped files with this simple transformation. But
it just dawned on me. I was thinking about this a little bit more, and I feel like part of this conversation strayed into the realm of either or, right? So Brian's proposal to do ANSI SQL and then potentially convert it, instead of a macro language? Why not both, right? Why not offer both?
Yeah, from my point of view, it's like a 2 steps. So the macro easy to implement and play with when you potentially identify the macro, but it's very limited. Yes, so in macro language you don't have the context, you don't understand the query, IST, so you can only do very simple stuff.
Yeah,
And
as long as the table names and the columns or the paths or whatever, however you want to talk about it, but as long as that core schema that we create is the same, you could use the macro language to automatically generate queries for multiple languages, or you could fire up your ANSI SQL editor, bang it out, bust open this SQL glot tool and translate it for multiple. You can do whatever you want, right? As long as the queries are targeting the same shape, it won't matter what tooling people use to make their queries cross-platform. So I think maybe that decision is not really a decision at all. It's really just, this is the technology we're using to demonstrate the power of this. It's a simple macro language for demonstration purposes, but you should feel free to write your queries however you want.
Yeah, we can do like FHIR. Yeah, like FHIR with a snapshot. So you publish not the generic query, but you dump all possible implementation sequels. Yeah, I agree. They are not contradict. So, but it still would be nice to have one representation by SQL on FHIR, and then have some special resource where you can put this SQL query. And I think we can take some part of DBT, like the view, make it resource, put the SQL query inside, and publish it. Yes, and then these resources may refer each other. Okay, and we are in FHIR world. But the translating, this is really interesting. I don't know if somebody have working demo, or let's see how it may work. So I personally like the DuckDB or Spark syntax. It's better than JSON in Postgres. So that would be nice if it's potentially possible to translate, but we see some crazy stuff with nesting different behaviors. I'm not sure that we will end up with defining the new dialect, like it always finishes. So the real dialect, the big query dialect, and we will have SQL on FHIR dialect. Maybe it's not bad. I don't know. So if we put some limitation and restriction on it, on this dialect, that would be nice. And then some hints that if you're on BigQuery, you can write like platform.
Yeah, we should probably just create our own database engine from scratch.
Yeah,
seems like the simplest solution here.
Yeah. Sorry, Ryan, you started.
Yeah. So I guess so planning, we're running low on time today, but so planning for next week. I mean, I will plan on, if the group's interested, I can do a demo of a FHIR path to SQL translation. It covers a fairly sizable set of FHIR path, probably more than these use cases need, and it is fairly complicated because of that. But we do have it working over BigQuery and mostly working over Apache Spark. That's a little earlier in the implementation for that. So if nothing else, I can show what's possible in that dimension, and we can. So I think that could be a good data point. And then, as we gather these data points, I mean, I agree with Evan's point. These things don't need to be mutually exclusive. I think my main goal is I want to make FHIR data easy to use, or I guess all of our goals is make FHIR data easy to use in for analytic queries. And depending on the use case, you may have different patterns. So we'll kind of show that. Maybe we can explore if there's a subset of FHIR path that's useful for use cases, and then and in parallel, I think exploring standardization ANSI makes sense. I do think that having a standard base layer as much as we can is still useful, still very helpful, because it means there's a lot less work to translate the different views to different databases. But I think that we found that there's always going to be too much variance in that base view. So I personally think that the more interesting area is how do we create an unambiguous description of flattened tables that is portable. If we can solve that problem, I think it's a huge step forward.
We need to stop the proliferation of every company in the world looking at this problem and saying, oh shit, I got FHIR and I used Databricks. Let me invent a schema, right? We want to stop people from doing that. We want to be able to have guidance and say, oh, you're trying to use your relational database technology with FHIR. Here's the schema to use. This is the guide. This is how you do this. This is how you get FHIR into a database. And then if you do it our way, you get all these other cool things, these use cases that were built on top of this. That's the sell that we get everybody to agree to use these base schemas that we're going to invent for people. And if we can get a large critical mass of people using this, it's going to create an entire ecosystem around this that will really advance the adoption of FHIR. So that's kind of where I'm thinking that this needs to go.
So Evan, a question on that. So I mean, so do you see like a sort of a well-defined set of like flattened tabular views? I mean, from maybe an NCQA perspective, where like there'd be, if we have like some corpus of well-defined flattened FHIR views, then a bunch of quality measures could run against that. Or what is the sort of delivery there?
So what we have been talking about is developing a base layer, and then as needed, people can invent views that are created against those base layers. Those views can have different shapes for different use cases. So for example, most people may not feel the need to have terminology in their databases. But when you're doing quality measurement, you absolutely want terminology in your databases, because every part of quality measurement is, does this resource have this code? It's what everyone cares about all the time, right? It's that and date checks. That covers 95% of your use cases. So you want that in there, right? But for other use cases, you may not. But for your core FHIR resources, I want to be able to create views that access those so that these views can be installed in any database that's using this schema. And that's just part of the installation process. Oh, you want to deploy quality measurement on your database? Install these views. The schema is called QM or NCQA, whatever it's called, right? Whoever's creating their schema, and then it just runs, and you can create cool reports and other cool stuff based on that execution. Because what we're seeing in the market right now is a lot of people are very interested in FHIR, and they're interested in quality measurement. Specifically, they're interested in digital quality measurement because CMS is screaming about it, right? But they have no idea where to start, right? They're complete FHIR noobs, and most of them have legacy databases. So I want to be able to tell them, ETL your legacy databases into this, or create a view on your legacy databases that maps to this base schema. And from there, you can have views on top of views, and everything will work for you. That's what we need to be telling people, because a lot of companies are starting this journey now. And if we don't offer guidance soon, people will invent their own stuff. And then we'll have a proliferation of everybody has their own schema. And I would prefer.
And Ivan, what are your estimates that potentially NCQA can publish some SQL on FHIR metrics, not SQL, I mean clinical quality language, but SQL on FHIR queries? If we get to this point, so we can provide kind of portable queries, can you imagine that you will publish some metrics in this format, or you stick too much to the clinical quality language?
So currently, we are in a weird position as NCQA, because we're very beholden to what CMS is doing. We have to march to their drum. So our hands are somewhat tied. We have to endorse CQL. I would not use CQL if I didn't have to. I don't think it's a great technology in general. It has a lot of problems. I would probably just write them in straight SQL, which is part of the reason I'm interested in this topic, this call. So the answer is yes. Whether we do that by translating CQL that we write into SQL using some techniques that it sounds like Ryan and Google have already gotten a head start on by doing FHIR, which is a big step. Or whether we say, you know what, we have enough of a useful base schema that we can just write pure SQL. I have a couple guys on my staff now who did that. There's some vendors right now, the compute he is using pure SQL. So it's possible, and they've done it before. So maybe we would.
Thank you. Bashir?
Yeah, just very quickly, just my 2 cents. I mean, having, the goal of having like a standard views, I mean, it's great, but to be honest, I am very skeptical of we can come up with some sort of, like a views set that covers even not everything, but like even like 90% of the use cases. So I think the use cases are diverging of that, maybe focusing more on how to define views, like Ryan was saying. Maybe it's a better kind of like a shorter term goal, and then some standard views may kind of organically be adopted. Like, people would say, okay, I use this and I create these views, and then I, with this, I can have these many metrics. And then people would say, oh, okay, I want that too. So I adopt that view as well. So kind of that organically that happens instead of us trying to come up, envision all of the use cases. Just my 2 cents, sorry.
Yeah. And I think that's what Brian promised us, like logical model with FHIR path extensions. I think that's what the view definition should be. Yes.
Yes.
Logical model, you put the FHIR path expression, what should be extracted, and that's your first step for the view, like basic view, and then you can join and define the other views. Yes.
CQL is like your macro language. It's a DSL to query a SQL database. Think of it that way.
Okay.
Right, Evan?
Yeah, you could absolutely do that. I don't know how suited the language is to that task, as it is highly
I mean, yeah, I write a
dubious
lot of
decisions made.
I write a lot of CQL. It's weird, but closure is weird too, and some people seem to like it. So I think it's you get used to all these things.
Yeah.
But it is a standard, and I'm bullish about well, like if we can come up with these lower layers in SQL for FHIR, I think it's just a mechanical task to translate ELM to that. It's just we need to figure out what to target, and and I'm excited about the Connectathon coming up where we can talk in person more about this. And I know we're at time. Sorry.
Yeah.
Let's do this. Yeah. I think the semantic of execution of SQL may not agree with you.
The issue you're going to run into, anyone who tries to go down this path, the issue they're going to run into is the fact that there are lots and lots of keywords in CQL that do not exist in SQL and are not native. Even the simple example that Nikolai came up with age, how it's done differently in different databases. There are so many weird interval calculations that you have to do, so much weird date precision you have to deal with. All of that is going to be super hard. So if the database does not support user-defined functions and possibly in some cases stored procedures, you might not be able to do it. And even if you can use user-defined functions, you might find that you need so many of them that the queries run really badly. Now, that said, I still think even badly running queries where the data does not have to go over the wire out of the database onto some execution node somewhere is still going to be orders of magnitude faster. It will approach real time as opposed to the current models everyone is using, which is unless you compute it as it's being streamed into the database originally, if you try to run a batch on a few tens of millions of patients, or dare I say members as in a health plan, it is going to take the rest of your life because you have to download the entire database. So, it's even really inefficiently written queries on a database are probably still going to be much better. So yeah, Brian, I'm bullish about it too. I think it is absolutely possible. And I think that's a really easy slam dunk use case for SQL on FHIR for sure. And I'm sure there's lots of others, but yeah, Brian, well, we should think this through a little bit in May.
Yeah, I can tell you the story. We discussed this translation for 6 years with Breen. So, I did like 5 years ago, I did experiments manually translating the SQL program to SQL, but since then SQL become more and more complicated.
Well, and the other thing you're going to run into is all of us have seen the false promises of the Hello World demoware. I like to joke that, they're Contoso applications. If anybody's ever read Microsoft documentation, they always use these little simple, oh yeah, look how great this is. It just works. And then you try to write a real application and you realize, oh my God, like WPF was a great example of that, where it looks so cool and wonderful. And you can make UIs with cool little markdown. And then you try to create a tree view that has icons and it takes you 8 hours and you think, what the hell, so the CQL demoware that exists right now is ECQMs. They're very simple. They're one file. They're trivial, right? That's what everyone shows in Connectathons and demos. Real world CQL, where you're doing actual computations like HEDIS, for example, that have complicated concepts like continuous enrollment. They're really hard to implement. You're talking about like weird aggregate functions and all kinds of weird stuff. It gets really hairy really quickly. So be cautious of looking at CQL and thinking, oh, this is easy. If you look at the breast cancer ECQM, oh yeah, that is easy. Try, one of the measures that has 14 numerators. They're all like, oh, well, any immunization that occurred within 14 days of another one doesn't count. Like that, those little type of rules, they just really make things complicated. So it'll be tricky, but I think it is doable.
Yeah, so Evan, I've got one follow-up question. So assuming, let's say that if we can work it out and it is doable, which I agree, there's quite a lot of complexity there. But you mentioned like the significant performance and potential performance improvements of running CQL natively on databases. Do you see, other advantages? It's like integration with analytics tool chains. What are there other reasons you see there?
Well, it's because for no other reason, right? Any CTO worth their salt will hear, okay, so you're telling me that in order to execute what amounts to essentially a query, I want to know, okay, given this data, who's in the numerator, right? You're telling me that in order for me to compute this, I have to download my entire database every single night and then execute it on the cloud, which is costing me money. So you can upload it back to my ETL, my analytics database. And then I can write Power BI reports on that, as opposed to being able to just do it in the data warehouse. When they say that and then they work that through and they just think, why would I use this technology? That's the hurdle that we have with CQL at the moment, right? And so everybody's twisting themselves around and trying to make the data dump more efficient. Brent spent a huge amount of time working on data requirements to try to minimize how much you have to suck down from the database. But it's solving the wrong problem, in my opinion. Don't suck any data down, just do it in the database.
And I think we can save a lot of energy.
Yeah. So, even in the best case scenarios, you can do lots of pre-processing to try to limit how many patients you look at. But if you want to be legit about it and execute every single patient and run a batch of measures, you're looking at hours and hours of time, most of which is spent downloading and deserializing, which could all be completely obviated by a pure native SQL solution. So it's the right architecture.
You can bring us some corner cases, yes, we should really see that will challenge us. So I've seen you created this about the age functions ticket, yes, but please give us more. we want more.
Man, I could write a novel about all the little corners that make you scream.
Okay. All right. I'm gonna have to take off, folks. Thanks everyone. This is good. I'll plan on doing a little FHIR path thing demo next week. Sounds like the group's interested in and then we can consider these other options as well. So appreciate it. Nikolai, thanks for hosting and herding all of the cats here. I know this is a challenging thing to do, so I really appreciate your time and effort in this space in particular.
Yeah.
Okay. Thank you, guys.
All right. Thanks.
Thank you.
See you next week.
Next week. Bye bye.